All right, everyone, buckle up. Because today we're going deep, really deep into
Okay.
the universe. But not just the universe you can see, like the stars and planets and stuff.
Right.
No, we're talking about the stuff we can't see.
Yeah, the hidden universe. The
Yeah,
stuff that makes up, well, most of everything.
exactly. Dark matter and dark energy. Have you heard of this stuff?
Oh, yeah. It's like one of the biggest mysteries in cosmology.
It really is.
Yeah.
So what we're going to do today is sort of a cosmic detective story.
Ooh, I like that.
Right. We've got clues, we've got evidence, but we don't have, like, a suspect.
Uh-huh, exactly.
So first clue, galaxies. They're spinning too fast.
Way too fast.
If you, like, took all the stuff we can see in a galaxy, stars, gas, planets, all of it, and you did the math,
Yeah, you'd think they'd fly apart, right?
they should be flinging themselves apart. But they're not.
Nope, they're spinning perfectly fine.
Like, what's holding them together? That's where dark matter comes in.
It's like the invisible glue, right?
Yeah. It's this invisible stuff that doesn't interact with light.
So we can't see it, but we know it's got to be there because of the gravity.
The gravity, it's adding all this extra gravity to galaxies and keeping them from,
They're spinning themselves into oblivion.
exactly. And get this, scientists think dark matter makes up like 27% of the entire universe.
Yeah, that's way more than the regular matter, the stuff we can see.
Way more. Okay, so I have to ask, couldn't there be another explanation?
Oh, for sure. There are some scientists who think maybe, just maybe, we need to tweak our understanding of gravity.
Like maybe Newton and Einstein weren't totally right.
Well, not totally wrong, but maybe their theories don't work perfectly on like super huge cosmic scales.
Interesting. So modified gravity is one idea, but what about what dark matter is?
Right. So one idea is that it's made of these undiscovered particles.
Okay, particles we've never even seen before.
Exactly. They don't interact with light, they just pass right through everything. Ghostly particles.
Whoa. So scientists are looking for those, right?
Oh, yeah, big time. There are these massive experiments going on, like at the Large Hadron Collider.
Yeah, I've heard of that. Smashing atoms together to see what pops out.
Exactly. It's one of the ways they're trying to find these WIMPs,
Okay.
weakly interacting massive particles. Catchy name, right?
I mean, it's better than ghostly particles, I
That's
guess.
true. But anyway, we're still waiting on those WIMPs to show themselves.
So, okay, we've got this invisible glue holding galaxies together.
Right, the dark matter.
But then there's this other thing out there,
Oh, yeah. And this one's even weirder.
dark energy, which, let's be real, sounds like something out of a sci-fi movie.
It kind of does. But this is real, folks.
Absolutely real. And it's doing something even crazier than dark matter,
Instead of holding things together, it's pushing them apart.
like anti-gravity.
Yeah. So back in the 90s, astronomers were studying these exploding stars called supernovae.
Supernovae, those are like the brightest explosions of the universe, right?
Yeah, they're insane. And by studying them, astronomers can measure how fast the universe is expanding.
And what they found was, well, kind of shocking.
It's not just expanding, it's accelerating. Like the expansion is getting faster over time.
Wait, so it's not like throwing a ball up in the air and watching it slow down?
Nope, it's like throwing a ball up and watching it like zoom off into space.
That's not how gravity's supposed to work.
Exactly. So something must be pushing everything apart. And that something is, you guessed it.
Dark energy.
Yeah.
But we don't even know what it is, do we?
Not really, no. It's like this giant question mark that makes up, get this, 68% of the universe.
68%? It's like the universe is mostly made of this stuff we don't even understand.
Isn't that wild? But you know, there are some interesting ideas out there.
Oh, like what?
Well, remember Einstein, the guy with the crazy hair?
Yeah, the genius.
So he had this idea called the cosmological constant.
I've heard of that. It was like this fudge factor he added to his equations, right?
Yeah, basically. He thought the universe was static, not expanding or contracting. So he needed this constant to make his equations work.
But then we found out the universe is expanding, and he called it his biggest blunder.
Famous last words. Because now, some scientists think the cosmological constant might actually be related to dark energy.
Like, it could be the energy of space itself, pushing everything apart.
Exactly. It's still a mystery, but it's a cool connection.
It really is. So we've got dark matter holding galaxies together, dark energy pushing the universe apart.
It's a cosmic tug of war.
And the big question is, what happens next?
Right. If dark energy keeps winning, well, things could get pretty wild.
How wild.
We're talking about a big rip, where the universe expands so fast it rips everything apart. Stars, planets, even atoms.
Yikes. That's not a good ending. Are there any other possibilities?
Oh, definitely. Maybe the strength of dark energy changes over time, or maybe dark matter finds a way to, fight back. We just don't know yet.
So we've gone from invisible glue to universe-ripping energy, and it's all stuff we can't even see.
Right. It makes you wonder, what else is out there? What other mysteries are hiding in the dark?
That's a great question to think about. Because, we've only just begun to explore the universe. And who knows what incredible, mind-blowing things we'll discover next.
That's what makes it so exciting, right? It really makes you wonder what else is out there. What are we missing? I mean, if we can't even see most of what the universe is made of, what else is there that we're totally blind to? Crazy to think about.
Totally crazy. Well, on that note, I think we've done enough deep diving for one day. But keep those cosmic questions coming, folks, because the universe is full of surprises, and we're just getting started.
Absolutely. This is just the beginning. There's so much more to discover out there in the dark. Who knows what we'll find?